How to plot various figures with Matplotlib. Hi everyone, we are here to talk about the legendary Python library, Matplotlib, and how to plot things with it. The code is on my GitHub with the link in the description. We need Matplotlib and NumPy to be installed before we start. The principle is simple. We create and edit a dictionary, configure the axes and describe the functions to plot. We shall import the necessary libraries here, then set the general style here and set up some utility functions to manage the axis styles, legend and color. Here we go with the most basic one, line plot. We create line dictionary to configure lines parameters like start and end points, the number of points, the colors, and a title. Then we define the lines functions and then use the ax.plot function to display them. The pattern will be the same. Create the variable x, use the ax to plot the graph combining x and the line functions. It is only used to plot lines. And there it is. Let us try plotting scattered points. We create scatter dictionary and configure points number of points, the colors, and a title. Then we define the scattered points by creating them randomly with NumPy and then use the ax.scatter function to display them. The pattern will be the same as before. Create the variable x, use the ax to plot the graph combining x and the scattered points. We can use it to print various points. And there it is. Thirdly, let us plot bar charts. We create bar dictionary and configure bars with color, edge color, and a title. Then we define the bar datas by creating them randomly manually, and then use the ax.bar function to display them. The pattern will be the same as before. Create the variable x, use the ax to plot the graph combining x and the bar corresponding. And there it is. At fourth, we plot an histogram, a graphical tool that displays the distribution of numerical data using connected bars. Its purpose is analytic, used mainly to repair frequency, data repartition and else. We plot it with ax.hist and the parameters discussed in the 3 previous points. Fifthly, we can plot a pie chart. It is a circular graphic divided into parts on a basis of 100%. A pizza if you prefer, ha ha ha. Its purpose is also analytic. You can see the parts of all the categories used for analysis. We use the programming languages in our example. Here we code the PIE, the pie datas, and plot them with ax.py. The sixth is the box plot. Basically, we plot boxes which represent 5-number summaries such as the minimum, the first quartile, the median, the second quartile, the maximum. Mainly used in data analysis. We create the box dictionary, create the box datas, and plot it with ax.boxplot. Next, we plot Heatmap, a map used to display data density and intensity depending on the location according to the abscesses and ordered. It is mainly used in website analytics, click/scroll tracking, geospatial analysis, crime/weather mapping, business intelligence, sales performance, and scientific research, gene expression. We create the Heatmap dictionary, its datas, and we plot them with ax.mshow. Contour plot. A 2D visualization that represents a 3D surface by plotting constant slices, contours, against two predictor variables, x and y. You use it to display the 3D plot for one value of the Z attribute. It is used for topographical maps show terrain elevation, where closer lines indicate steeper slopes, and geographic mapping barometric pressure, isobars, in metrology. We create the contour dictionary, then the Z values needed, and we plot all with ax.conturf. After seeing the dismantlement 3D, we can plot the all-in-one 3D surface. We create the surf dictionary, its Z values, then plot it with ax.plot_surface. Next we plot polar graph. Its unique difference is that it plots polar values coordinates considering the angle and the radius rather than the x and y values. Let us create the polar dictionary, the polar values, then plot it with ax.plot simply. Fill between. Here we will see how to fill the space between two courbes. For that, Z, like always, create the fill dictionary corresponding. Then create the two functions of the courbes, and plot them with ax.plot, and fill the space with ax.fill_between. And there you are. The last but not the least, we plot a step plot, a graphic of data points connected by horizontal and vertical line segments. You can see them as a staircase pattern to show abrupt, non-continuous changes at specific intervals. We use it, for example, in finances to display changes in interest rates, tax rates, or stock prices over time. In engineering to show step responses in dynamic system models to observe abrupt changes. We create just like before the step dictionary, the steps values, then plot it with ax.step simply. For those interested, the code is in the description. All the elements are in the same file, just need to the plotting function to display all elements viewed in the video. Thanks for watching. Feel free to enjoy them all and subscribe for more programming tools and videos like this.